Welcome to Evolving Code. My name is Paresha. In this episode, we will see the relationship between Fluent APIs and refactoring. That is, we are going to see how Fluent APIs influence refactoring. For those of you who don't know what is refactoring, it is making a change to the code which does not result in a change in its behavior. That is, the code changes, but its output doesn't change. Then you might be wondering what is the purpose of refactoring. It's essentially to change the structure or design of the code so that it is better maintainable. For the purpose of this demonstration, I will use an existing Fluent API in Java. So let's start with the code you see on the screen. I have a instance of string builder which is called accumulator. Then to the accumulator I am going to append multiple values. So you see some are integers, some are strings, and let's start by running the code first. So you'd see that it's building a mathematical expression. If you look at the API here, each time we append, the state of accumulator changes, and finally we convert it to string, and in this case we just print it on the console. So it appears as if the append methods, all of these append methods, they are void because you take argument, the change is made into this accumulator which carries the state, right, as and when we make this append, and finally we get the final state from the accumulator, right. It appears as if append methods are void, but if you look at these, you would see that they are not void methods. They all return the same string builder upon which the append methods were called. But if you look at this piece of code, we really don't need that returned value for our logic of constructing an expression to work. You see that we have not assigned the result of append method or the returned value from the append method to anything here, and still we are able to construct our expression as we saw in the output. Then you might be wondering what is the use of this return value. Let's see that with the help of refactoring. But before getting there, let's look at this piece of code and see what challenges do we see in this code. The first one we see is that you see accumulator dot append, accumulator dot append. So many times accumulator dot is repeated. What is the consequence of this? The way I would think while writing this piece of code is, I have this accumulator which is an instance of string builder, right? Think about that right in the beginning. Then I will not focus so much on the accumulator. Then I'll think that, hey, I have this accumulator and I want to append all these values to the accumulator. So the focus goes on what I want to append. But since I am forced to type accumulator dot every time, that acts as a noise, and signal to noise ratio comes down in this code, which hampers the readability and ability to focus on the most important part while writing the code, that is the sequence of all these append operations. And what happens is, with every time I type this accumulator dot, my brain wants to focus less and less on the accumulator because it's a repetition, right? As a result of this, it's possible that you might accidentally use another variable which is similarly named to this variable accumulator. So those are the two disadvantages of this piece of code. Now that we know this, let's and we also know that append method returns the string builder. Let's start refactoring this. So what I will do is I will assign the return value to the same variable, which is accumulator. Let's run the code once again to make sure that we have not broken anything, which looks good enough. Now that I have this, I will try to inline the accumulator from the last. That is, if I look at the select just one of the accumulator, then I have this inline variable. So I'll do that just by applying the keyboard shortcut. So you see that now the accumulator got replaced with accumulator dot append 30. So I'll keep on applying this until I exhaust all the appends. You would see that we have changed the append methods. Let's make this code look slightly more beautiful and readable by moving each appends to their own lines. Now moved them to separate lines, and let's once again run the code to make sure that we have not broken anything. The code looks good. Now if you look at the previous two disadvantages, I'm not repeating accumulator dot anymore, so my brain can focus on what I want to append here, and there is no chance of accidentally using another variable which is similarly named as this variable accumulator. So we have ended up with the more readable, more concise code. This could happen because we have a Fluent API. That is, each append method returns the string builder object upon which I can call the subsequent append operations. Now, if we ask, are there any disadvantages here compared to the original code we started with? What if I want to know the intermediate state somewhere so that I can say print it and debug it? Right? Suppose I want to understand the state after appending 20, because let's say I'm getting some incorrect output. So I want to log this and see what is the value, intermediate value at this stage, which I can't log in this structure of code, which was possible in the beginning of the code where we repeated accumulator dot accumulated. Right. So let's what we'll do is we'll select this expression, that is new string builder dot multiple append till we append 20, and in this case we can make use of refactor, extract or introduce variable that can be made use of. So let me just use the shortcut to introduce a variable. Let me call it as accumulator, and I don't need the initial declaration part. It and I can now use this accumulator dot say to string, and I just want to print it. Let's just run the code once again, make sure it's correct, and it looks all good. Now say we have figured out what happens here, and you have debugged. Now let's say we don't want this form anymore. We want to go to that all chained methods. We can delete this here, and I can select this value and do inline once again, and now we have gone to the all clean method chaining structure what we have. By looking at this example, we can learn that refactoring helps us to move the code from one structure or one design or one representation to another structure or another design. But specifically when we had a Fluent API, that structure itself lends better for refactoring. That is, since we have Fluent API here, we could easily apply extract variable or inline variable refactoring, and we could easily change code from one structure to other structure. So this is the benefit of Fluent API, that it makes it easy, or it simplifies, or it lends itself better for refactoring. So finally, we can say that a beautiful code is one which supports evolvability, right? Evolvable code is beautiful code, and refactoring skills is what helps the developer to keep the code evolvable. So I hope you found this video useful. Have a nice day and see you in the next episode. Thank you.